Hi everyone, I welcome you all for my Java 8 video series. In this video, we are going to discuss about functional programming. In our earlier video, we discussed about the Lambda calculus, the fundamental of Lambda calculus expression. We got a detailed understanding of why we use Lambda calculus. Now in continuation to the Lambda calculus, now we are going to deal with functional programming, which would be the implementation of your Lambda calculus. Now, this functional programming is a programming paradigm, meaning it's a programming pattern which need to be followed in the functional programming standard. All you deal with here is a function. You will see only functions in it, and we will follow the style of functional programming here. And this term called functional programming rooted from mathematics. And specifically in mathematics, we have a Lambda calculus. So it is based on Lambda calculus, rooted from mathematics, but based on Lambda calculus. Language independent, what does it mean? Now, you can apply this functional programming standard in many languages. So you need not be very specific that X language alone supports functional programming. Now actually, to simulate this, we need to differentiate a functional programming with an object-oriented programming. If you look at the object-oriented programming, we can name some programming languages which follows the standard of object-orientedness. Number 1, your C++. Number 2, Java. Number 3, Python. Number 4, C#. All these languages follow the standard of object-oriented programming system or programming model, like which functional programming were there in the existence for ages, and it was followed by many older languages which actually non-existent in today's market. So functional programming is more similar like a programming standard in object-oriented programming model. But there you will deal with objects and classes, wherein in functional programming you're going to deal with functions alone. And more interestingly, functional programming has certain rules in it. The variables which you forward to the functional programming, those variables' value cannot be changed, or you cannot make it as a mutable data. So all variables in functional programming to be treated as immutable data. The meaning of immutable data is the value for the variable cannot be changed. If you change the value of that variable, it is not helping to define a functional programming in it. So, a programming style that treats computation as the evaluation of the mathematical function. So, functional programming is treating the same pattern like a mathematical function, where it avoids the changing state of the variable's value, and also it becomes a immutable data, meaning is avoids the mutable data. Mutable data means data can be changed. But you are trying to avoid the mutability of the data in your functional programming, which is more similar like in Lambda calculus constraints. In Lambda calculus constraints also we used to follow the same. When I'm saying f of x equals x plus 1, if we provide a value to x as 2, the output is always 3, means you can predict the output because the value of the variable will never change. If you give a f of x as 3 and 3 plus 1 is 4, but if you get 5, then the operation internally to the Lambda calculus in the black box is actually modifying the value of the variable, which you should not permit to in functional programming. This is a very important constraint that I'll be discussing throughout this course of video. So what we are discussing here is all about what is functional programming. Why we need to learn this functional programming? Because Java 8 follows the functional programming standard, but all rules are not applied in Java 8 functional programming. Even though functional programming has some rigid number of constraints in it, all constraints will not be followed in Java 8 functional programming, but it is based on this functional programming paradigm. Now, in functional programming, functions are treated as first class object. So what I mean by first class object? The first class object means the very first object that you will see in the functional programming is none other than the function itself. So everything you see there is a functions there. So functions are treated as a first class object. So for example, you are declaring a function and you are calling a function. That is what we generally do in a functional programming. So we declare one function, let's say add function, and you define the function there, and then you call the function add by providing the parameter for the function like a comma b, which is 10 comma 20, and then you get the output as 30. So add is a function which is declared and defined, and moreover it's called. Apart from doing a declarations and calling the function, you also perform furthermore activity on it that contributes to the definition of the functional programming. So functional programming is not just about declaring a function and calling the function alone. If you look at the other angle of the functional programming, you can actually pass the function as an argument. So you have a function A, and function A can take an argument of another function, right? So generally a function will take the argument as an object, or it will be a variable where it takes a primitive value as an parameter. But now in the functional programming, what they say is a function can take an argument of another function, plus a function can return another function as a value. It can even return a function as a value. So usually you say return 10, return a plus b, return the object. But now you can return the function itself. So function will be taken as an argument in another function, or function will be returned by another function, or you can assign a function to a variable. So let's say int a equals 10. So what I do here, 10 is assigned to a variable called a. But here in functional programming, the whole function can be assigned to a variable. That's why we say functions are first class object. Now, coming to the pictorial understanding, I have defined a function where it is not carrying a name in it. You can see that I'm highlighting here. This part of expression is actually contributing to the functional programming. Why? Because this is your function code. It doesn't carry a name in it. It's an anonymous function. The whole function is assigned to a variable called var. So the first thing is achieved. You can assign a function to a variable in a functional programming. Second, you can return them as a value. So I have a function here called add, and the add function returns another function, where again here the function is not named, so it is all about anonymous function. That's what we do in the Lambda calculus also. Lambda calculus abstracts the expression, and also it doesn't carry any name in it, right? So if you look at here, this snippet of expression is actually returned, but that expression refers to the function here. Then you have another attribute of a functional programming, which is nothing but accepting as an argument. So now add function takes in a parameter called var. While you call the add function, you can actually pass the whole function, which is again an anonymous function, to the variable, to the argument variable to say. So the first one what you saw here was a function which can be assigned to a variable, and a function which can return another function, which is again a representation of anonymous function here, and a function which can take a function as an argument. So as in this case, add function is called by passing in an anonymous function to the argument of that function. So these are the three major attributes of functional programming. So apart from declaring and calling a function, you can perform a function assignment, a function return, and a function as an argument also. This gives the more detailed understanding of what functional programming is all about. So let's summarize of functional programming. So functional programming traditionally have no name in it. So you will not declare a name for the function. So you will not go for a separate declaration of a function. It's a one-liner of statement like. Most of the programming languages who supports functional programming will dictate that it carries a single line of functional statement in it, which is contributed as a function itself. So as in the previous demo, in the previous diagram, we saw that everywhere we were declaring a one-liner of function code in an anonymous fashion. So technically speaking, functional programming will not carry any name in it. So this is exactly what the abstraction syntax in the Lambda calculus does. If you recall the Lambda calculus video, which I discussed in the earlier sessions, you can actually capture that the abstraction layer of the Lambda calculus is nothing but the anonymous function in it. So in functional programming, anonymous function represents the abstraction syntax of the Lambda calculus. So as a result, many languages, including Java, have started to implement first-class function. Means in Java, henceforth, we can assign a function to a variable, we can return a function from another function, or we can pass a function as an argument to another function, so that Java also supports your functional programming standard, which treats it as a first-class functioning code. So functions without an explicit name declaration is called as Lambda expression here in Java. So Lambda expressions are nothing but a functional programming code which doesn't carry a name in it. So Lambda expressions can be seen in three places. One, a Lambda expression can be assigned to a variable. A Lambda expression can be returned from a function. A Lambda expression can be passed as an argument to a function. So ideally, when you see this, a functional programming is exactly applied in Java 8 with the help of a technical term called Lambda expression. So Lambda term comes from your Lambda calculus, where the functional programming resembles your Lambda calculus strategies, and so the Java 8 have kept the term called Lambda in it. Most of the programming languages used to call this as a Lambda. Either they will call it as a functional code, a functional programming code, or they will call it as a Lambda expression. Even Python supports Lambda expression, Java supports Lambda expression, JavaScript supports Lambda expression. Meaning is all these three languages are supporting functional programming in it. So what is the conclusion of that functional programming? Assign a function into a variable, return a function from a function, pass a function as an argument to another function. That's all. With this, we define that these standard of code resembles the functional programming in it. So in the next video, we are going to discuss about functional programming paradigm more in detail.